evening, everyone. Our team name is Equipa Marcias, and that is actually Roman for Team Mars. We are from Our Lady of Guadalupe High School, and we're from Belize. So our team is divided into different sub-teams. We have the design team, which is Jose Rodrigo, the plant team, which is Erin and myself, and the energy and water team, which is Anjali and Lena. We were guided by our mentors, Mr. Daniel Adamo and Ms. Rose Werku, and our team teacher is Mr. Emil Pulido.
Our inspiration. This inspired us as students because we got the opportunity to be able to design a greenhouse that can sustain plants on Mars. We were given the chance to participate and contribute towards something so great and amazing. I'm pretty sure if you asked us, none of us would say that we ever thought we would be designing a greenhouse that can actually survive on Mars. We also got to interact with different people from around the world, including professionals who specialize in this field. Some of the challenges we encountered many challenges along the way, like having to find the best plants that can survive on Mars or having to choose a type of energy system. However, our biggest challenge was actually deciding on a type of soil. Earth's soil was too expensive to transport, but Mars's regolith soil contains many harmful chemicals. When we saw Ms. Rosa's hydroponic greenhouse in the Mars simulator, that pushed us to choose a hydroponic system instead. It also became the reason why we decided to use the human's habitat resources for our greenhouse.
Now onto our greenhouse. We decided to have a deep water culture hydroponic system. We plan to use the human habitat's resources and have the crew maintain the greenhouse. As you can see, the length of the greenhouse is 1.5 meters and the width is 0.60 meters. It is also 0.20 meters deep. There will be an air stone powered by an air pump and connected through an airline. On the top of the container, we'll have a styrofoam raft to hold the plants. Finally, at the top of the greenhouse, there will be adjustable LED lights.
Okay, so for our greenhouse, the plants we chose are kale and lettuce. And the reason we chose these is because these plants are actually among the most nutrient-dense foods. So they contain different nutrients like vitamin A, vitamin C, and vitamin K, which is beneficial for the crew. Apart from that, they can even help keep the crew hydrated, as just raw lettuce is actually made up of more than 95% water. Another main reason we chose it is because both plants not only can they grow in polar temperatures, which means they survive on Mars best, but they also grow really well in deep water culture hydroponic system, which is the type of greenhouse we designed. We want to be able to germinate the seeds in the greenhouse, so we would plant them into the hydrotons in the net cups, as you can see in the diagram, and they would be submerged into the nutrient solution, which actually uses urine as fertilizer. We're gonna have artificial lights, LED lights, red in colors red and blue, because that's the color light spectrum that plants need. And after plants reach around like 4 weeks, even though they wouldn't be matured, you would be able to cut leaves that are further away from the head, as even though you cut them, they will regenerate, so you can practically use plants over and over again. But then after 2 to 3 months, hopefully then the plants would have matured and they would have flowered. The crew would have been able to collect the seeds and store them by cryopreservation. And then you can harvest them and practically reuse the greenhouse, because you can use the seeds that the crew had collected.
Okay, hopefully you can hear me well. I'm currently having some internet issues, but anyways, for our energy systems, we chose to have 2 separate energy systems in case our main source of energy, which is solar power, in case that malfunctions. So the PV, or the photovoltaic solar panels, will produce about 1 kilowatt of electricity per Martian day to power our greenhouse. And considering the fact that Mars receives about 43% less sunlight than on Earth, we will also need a very large solar panel area. And that will mainly consist of, it will be around 100 square meters, and each square meter will produce 10 watts of electricity. And because of the frequent dust storms that happen Mars, will also be steam, and as you can see in the diagram, they will have an efficient battery that 10 kilowatts of electricity in case there is no sun, like during the night or during a dust storm. So for the MMRTG, or the multi-emission radioisotope thermoelectric generator, they will act as a redundant system. So that means they're safe. And about 10 of these generators powering our greenhouse in case our solar panel goes out, solar power goes out. It says 6 there, but I think that's a mistake. Yeah, it's supposed to be 10.
So now moving on to the hydroponic system. The required materials for the deep water culture hydroponic system is an air pump, an air stone, air line, and a nutrient solution. As we all know, the air stone is to keep oxygen, which will have the nutrient solution circulating and also prevent the roots from suffocating. The nutrient solution, which is urine, and we will use this for our greenhouse, and it requires a ratio of 3 parts water to 1 part urine. So the calculations we came up, and we need a minimum amount of 135 liters of water and 45 liters of urine for the container. The diagram shows that the lid is removable, so the crewmates can check the pH level of the water and also refill and clean whenever needed.
Here is a 3D model of our greenhouse in its full glory. As you can see, one container will have the lettuce, the other will have kale. There's the 2 air pumps that will connect to the air stone via air line. There will be this nutrient solution inside the containers. And again, there will be the LED lights at the top.
Some cool skills we learned are teamwork and social skills. We had to learn how to step out of our bubble and interact with our teammates and ask our mentors questions and put ourselves out there by volunteering to present. We also learned how to find different websites with correct and useful information, to create short pointers from long paragraphs. On the other hand, we gained some knowledge on the different water and energy systems. For example, the hydroponic system and the solar energy system. Additionally, we figured out how to balance school time, personal time, and all the meetings we had throughout the week. As a team, we learned how to use different information from different websites, our mentors, and maybe even some family and friends in order to create our greenhouse to the best of our ability. Some things we would do differently would definitely have to be to meet up more and share ideas and have a more organized presentations and say who is going to do what slide. We would definitely be more optimistic, meaning that we'd be more hopeful and more confident in our presentations and our ideas that we will share. We also would like to have more prepared questions for our mentors. Next slide, please. Thank you. For other students who want to participate in this project, the advice we would definitely give them would be, you cannot be shy. You need to be able to speak up. You need to be able to interact with others, ask your mentors questions, and don't be afraid to volunteer to present. You also need to have a planned out and organized schedule. This schedule will be your best friend. You also need to be willing to sacrifice your free time. Sometimes you might feel, oh, I don't want to work on this right now, but trust me, it'll all be worth it in the end. Lastly, don't get discouraged. Remember, your friends and your family are rooting for you. Your mentors are rooting for you. Your teachers are rooting for you. Remember, you're not alone. We're all in this together. We feel like this project is important for Belize because this gives Belize recognition from other countries. Imagine the US saying, hey, isn't that Belize that participated in the Martian 2.0 project? Their students had some brilliant and amazing ideas. We would love to hear that about Belize. This also opened new doors for newer generations. If a child wants to participate in this field of science, they would already have some experience. So by the time they're at a higher level of education, they would have an upper hand from the other students. This also gives youth the opportunity to participate in projects like these. This not only teaches you about Mars, atmosphere, and Mars soil, this gives you life skills. This teaches you how to present well, how to interact with other people. So if you go to if you go somewhere else to go to college, you will have the experience to communicate with other people from different backgrounds and from different places. Thank you.
Thank you to everyone for their kind attention, and a special thanks to our mentors and teachers who guided us throughout this whole process and who without we wouldn't be able to do this presentation or even come up with such a good idea for our greenhouse.